All right. Hey, everyone. Thanks for being here and joining us today for another Friends from the Field webinar. This one is called Putting Together the Pieces of the PFAS Puzzle, which is a real tongue twister. My name is Maren Brock, and I'm the Outreach Coordinator for Blue Hill Heritage Trust. And these webinars are co-hosted with Island Heritage Trust. So we also have Noel from Island Heritage Trust on the panel today. And before we begin, I wanted to say that we've been doing these webinars for a few years now. And if you're interested in looking at past webinar archives, you can find them on our website or on our YouTube channel. All of our webinars and online resources are free and open to the public, and every person is welcome to attend and take advantage of these learning opportunities. So if you appreciate the work we do and are interested in making a donation or contributing to our work, then you can donate on our website. And if you're already a donor, then thank you for your support. Our next webinar is going to be called All About the Eclipse with Terrence Finnegan, who is the Eclipse Coordinator for the Gulf of Maine Research Institute. And that webinar is going to be on Thursday, April 4th. So I hope you all can make it. All right, and now I'm going to pass over to Noel, who will talk about some housekeeping and logistics, and then we'll introduce our first speaker.
Thanks, Maren. Hi, everyone. I'm Noelle Ruth. I'm the Outreach Manager for Island Heritage Trust. We have a great presentation. So excited to be joined by Michelle and Charlie to bring us into this topic that so many people are curious about. If any questions come up for you throughout the presentation, feel free to use the Q&A feature on Zoom on the bottom of your screen to submit a question. And then at the very end of their presentation, Maren and I will read the questions out loud to our panelists. So for today's webinar, we are lucky enough to be joined by two local scientists today, Dr. Charles Rolsky and Michelle Berger from the Shaw Institute. Charlie is the executive director of the Shaw Institute in Blue Hill, Maine. He received his master's and PhD from Arizona State University's Biodesign Institute, where he researched plastic pollution in marine and terrestrial ecosystems. As a postdoc, he researched green chemistry and sustainable materials science. Charlie and his research have been featured on ABC News and PBS, and in the pages of the New York Times, Newsweek, Washington Post, Forbes, and Smithsonian Magazine. Currently, he focuses on researching links between environmental contamination and human health, which includes plastic pollution, PFAS chemicals, and other contaminants. Charlie is extremely passionate about citizen science and public outreach, with groups ranging from to lifelong learners. A teacher for over 8 years, he continues his mentorship through a range of internship and educational opportunities at the Shaw Institute. And I'll pass it back to Maren to introduce.
Thanks, Noel. So Michelle, our other speaker, Michelle Berger is the Associate Scientist at the Shaw Institute. She's been with the Shaw Institute for 18 years, except for a brief stint at the Jackson Laboratory. Michelle received her master's degree from Binghamton University in New York, where she studied the social behavior of parakeets. After receiving her degree, she worked on various research projects that combined her love of data crunching with her love of animals and ecology. Since working at the Shaw Institute, Michelle has focused on studying the impact of manufactured chemicals on human and marine mammal health. Along with Dr. Susan Shaw, she's published peer-reviewed research on the presence of environmental contaminants such as PCBs, flame retardants, and PFAS in top marine predators from the Gulf of Maine. Recently, she has turned her attention to monitoring bacteria and PFAS pollution in local water resources on the Blue Hill Peninsula. And so, without further ado, we're going to hand it over to our speakers.
All right. Well, thank you, Noel and Maren, for having us. It's great to be able to have this conversation. It's a really important topic for us, and we're very passionate about it. So we appreciate the opportunity. I'll share my screen. I also don't like hearing all of my bio, but I'm told by our marketing person we have to include that stuff. So whatever. Our very exciting conversation today is titled "Putting Together the Pieces of the PFAS Puzzle." I'm grateful to have Michelle on this as well. This is relatively new for the Shaw Institute, so we're grateful to be able to talk about it and go into a little depth about the work that we're doing. So as was said earlier in that gross way, my background has been kind of unique. I'm a biologist by trade, but I got all of my grad school training in engineering labs. So it was very instrument heavy and instrument focused, which was really a shock for me. But I found that if you surround yourself with people smarter than you, it has a tendency to rub off, not always. So again, much of my time is spent pursuing these kinds of things at the Shaw Institute. I also am really passionate, as they said, about outreach and citizen science. Charlie the shark likes to dress up as, I guess he's not, doesn't dress up. Charlie the shark is a shark, and he likes to read books to kids about the planet and the threats that the ocean faces. So it's also a lot of fun for us to be able to take the science that we're researching on a daily basis and convert it into something tangible that people can connect with on different levels. And we're very passionate about it and fortunate to be in a community that also, likes to learn about science and the planet around us. So we kind of start with the problem here. So PFAS chemistry was discovered pretty early on, talking about around the 1930s. These chemicals have a really, really unique ability to repel oils and waters and stains, and it has a very high chemical and thermal stability. So much as the case as with other chemicals and things that we tend to make as humans, this started out with really good intentions. We wanted this to have benefits to ourselves, right? We wanted to take advantage of these properties to be able to improve things around us. And again, like other things that we've created, whether they're chemicals or other contaminants, we found starting in the 70s and around the 1990s that there was research done on the blood of workers that were exposed to these items. And then further work was done to be able to actually link these chemicals to adverse health effects. So these chemicals are so strong, and in this case, they have such a wonderful ability to withstand high temperatures that it's almost impossible to get rid of them. So we're now kind of facing a really uphill battle. And now PFAS, the use itself by the industry has changed since the early 2000s because they started to notice these effects and they started to phase out certain chemicals and replace them. But much as the case, when you replace something and you want to replace it really well, you have a tendency to replicate those things about it that make them dangerous to begin with. So it was a bit of a pickle for us in that sense, that we were trying to make these replacements and so close to the chemistry of what they were replacing, it didn't deviate enough to then be safe, healthy, sustainable, anything along those lines. Now you see the word PFAS a lot, and it's all over the news and all over the headlines. But it's actually a huge group of chemicals that's growing on almost a daily basis. Now, PFAS and PFOA, as Michelle will talk in more depth about later, really got the ball rolling with the attention. And that's probably what you'll see most consistently when it comes to any type of news. But we've got a lot of different classifications that have different chemical structures for different reasons. So you've got groups of some sulfone groups in there, some carboxylate groups in there, and that ended up getting early attention after the PFAS and PFOA got recognized. And then more recent attention, you've got some fluorine-based chemicals that were then used for different reasons. Now we're talking about replacing these chemicals with other things, and you alter the chemistry a little bit, but you still want to retain those properties that are important. And then it ends up getting, more and more attention, more and more chemicals. And when you zoom out, it's actually a little bit overwhelming when it comes to looking at it from a kind of an outside perspective. And so this really kind of highlights what has been created up to this point. But this triangle encapsulates many, many, many different types of chemicals that are within this category. So it can be a little overwhelming at times, but at the end of the day, they all have functions where they're supposed to be able to withstand certain factors. Now, again, if you kind of think back to when this was created, you could ask people, if your house catches on fire, do you want the stuff in your house to be able to withstand those flames, or do you want the fire to hopefully die out? Now, maybe logically, if the house is on fire, that stuff that's in it might burn anyways. But again, it was created as a way to be able to withstand things like fire and stains, and it to be more of like a surfactant. The same goes with firefighting foams. We know that these foams are actually, they used to be laden with these chemicals, again, for a good reason. If you ask a everyday firefighter, do you want to be able to spray stuff on the fire that's going to put it out in a quick way that is safer for you? They're going to say yes. And then if you ask them, well, do you want to wear PPE that's going to be able to repel and withstand the heat? They're going to say yes. Now, obviously, we know that these chemicals that were used were fairly toxic and can be linked to things like cancer, which is horrifying. But again, this was created out of a sense of need. So it came from a place where we weren't trying to cause, well, we weren't, what scientists weren't trying to cause this, and the chemical industry weren't trying to cause these really harmful things, but it ended up happening as a result. And it's been really a tough struggle ever since then to make progress in this space with alternatives. It's also really difficult to get rid of. When you have something that's able to withstand heat and a lot of thermal degradation, chemical degradation, it's a really difficult group of chemicals to deal with. But again, it came from a place that wasn't necessarily a bad place. Now, it's a very complicated web and it's dynamic, just like a food web is, or looking at any type of ecosystem. We know that the PFAS chemicals themselves can start within the industry, for example, go into some of our consumer products, and then we might dispose of those. And we know that things that end up in a landfill or wastewater treatment plant don't always stay there. So then it can end up in the environment that way. We also know that firefighting foams can end up in the environment, or if we've got a day where a big fire station is washing their truck or their PPE, that's another way for the water that's washing the stuff to go into the environment. And then you've got the average product. So you've probably heard that things like popcorn that you put in the microwave, that wrapper has PFAS in it. There's also a lot of cookware that has PFAS because, again, you want that water repelling. You want that all stick so that your eggs don't stick to the pan in an annoying way. But that's kind of the thought behind why it ended up there. And we know that ends up leading to not only environmental exposure, but also exposure to humans. And this is something that's been studied now for almost, 50, 60 years, but it's still in its early stages of being able to make these connections. It's not always easy to link one thing to a harmful output when there's a lot of exposure in our lives on a regular basis. But that said, we're making quite a bit of progress in this space, and things tend to kind of go over the environment and towards humans because we're always so worried about our own exposure. But there's a lot of questions that still remain around environmental effects. And the Shaw Institute has been studying the effects of contamination on the environment for many years. So of course, this is very interesting to us. As research came out, there started to be more and more links between PFAS chemicals and human health. Now, some of these links, there's a high certainty that that's the case. And then there's other links where there's a lower certainty, but it's a probability. So an example would be neurotoxicity. That's suspected because we know PFAS as a chemical has these qualities that can disrupt certain neural functions. But there's other things like an endocrine disruption from PFAS that's been established with more certainty. And this is certainly something we don't like to see, especially in a situation where there's a pregnant woman or a fetus developing. It's not something that should be anywhere near our bodies. It serves a certain function as a chemical, but as a pollutant, it's pretty scary. Things like the liver, the kidney, the pancreas, those are all considered to be a certain probability in terms of health effects. So more and more stuff is coming out about this, and it's not looking good in terms of our exposure. Now, I don't always like to be doom and gloom with these things. We can understand that as a chemical, it serves a function, right? We talked about that before. One of our speakers that we had at the Shaw Institute last summer, his name is Dr. James Brown. And what he does is he looks at things like PFAS chemicals. He looks at the chemistry of it, and he tries to figure out what about the chemistry of this PFAS chemical, for example, causes some of these negative health effects, or how can we look at the bonds to understand what makes it resistant to thermal degradation. And what he does is he can, in some cases, reduce the chemistry down to maybe even a single molecule or ion, and then rebuild it with green chemistry. So what they started to do is focus on things like foams, and how can foams be used in this case to repel fires instead of using PFAS chemicals. And what they would work on a regular basis is creating these really unique materials. This is an example. It's not the same foam as what they were working on at the time, but they can basically recreate something that acts and looks a lot like plastic, but is actually sustainable, built with green chemistry and designed to degrade into things that are good for the environment. So it's a really promising way for us to be able to look to the future of firefighting in a way that's more sustainable, more biodegradable, and not going to have these really adverse health effects. For me, this is almost the future of the industry, only because they can replicate it without having those same negative effects and same bad effects on the environment. You might be asking, well, is that similar to the flame retardants before, where you're making something that acts like PFAS so well, it has those same effects? With these folks, they're able to see exactly what goes on within the chemistry that causes those really negative effects, and they can absolutely avoid it. So I'm confident that they're able to do this. And I'm very excited for the future of this industry, because I do think that there's quite a bit to be excited about in this space. Now, before we go any further, we all know that Maine has been laden with PFAS issues. And in my space where I used to work before, we studied wastewater treatment plants, because what goes into a wastewater treatment plant from your houses versus what goes out of the wastewater treatment plant, they're two completely different situations. But in essence, they're designed, these plants, to remove things like pathogens and smells from organic matter. And then what it does is it creates a really rich fertilizer in many cases. Now, this is assuming that things like PFAS chemicals aren't in the fertilizer, but generally what happens when those solids leave a wastewater treatment plant is they'll either be incinerated, land applied, or sent to a landfill. And much is the case with Maine, where a lot of those biosolids were actually deposited on land in a beneficial way. But at the time, they didn't know there was so much PFAS contamination in these wastewater treatment plants. So one of the suspected sources for PFAS contamination in Maine is thought to be wastewater treatment plants and the biosolids and sludge that leave them. So Maine not only had one of the worst contamination rates in the country, but it also had one of the most proactive responses to PFAS contamination. So the state ended up adopting a $70 million plan to not only help farmers deal with PFAS contamination, but allow researchers to study it, allow them to look at plant uptake, allow them to see what's the best removal strategy. And it was a really strong approach to fighting this battle and helping Maine farmers. And I'm really proud to say, based on the work that Michelle and I have done, that once we presented this to the state, they actually sent us an official request to be on the research side of this fund and help address from a scientific standpoint how the money can be best utilized. So we were really proud to say that we were looped into this whole movement by the state of Maine and by Governor Mills and the entire group of people working on this, which is really impressive, folks from the University of Maine. And what I'm really proud about, especially with this group of people, is that the farmers are right there with us. So we have all sorts of community members that have a vested interest in PFAS and are affected by it. And the Shaw Institute is proud to say that we're aiding in this as best we can. So without further ado, I'd like to pass this off to Michelle. And what Michelle is going to do is focus especially on this aspect of our research. What happens in the environment? How is it being studied? What's been done before? Are there similar effects on people as there are marine mammals, for example? So with that, Michelle, if you'd like to take over, I will stop my share.
Okay, thank you, Charlie. Let's see if I can get this working here. Okay, hopefully that's working.
We're seeing the wrong screen, I believe.
Okay, let's see.
There we go. Yes.
Okay, excellent. All right, let me just move this thing out of the way. Okay, here we go. Thank you, Charlie. Now that you've had a really good introduction to PFAS, what they are, and some about of what the state of Maine is doing, I'd like to tell you a little bit more about what we've been doing as far as local work here at the Shaw Institute. And I will briefly revisit this figure. As Charlie mentioned, we know that PFAS escape from industry, our commercial products, they get into the environment. And one part of the environment, which is very often a final sink or a final place where chemicals end up, is in the ocean. And once they're in the ocean, and this applies to PFAS as well as a lot of other kinds of chemicals, but they have a tendency to bioaccumulate up the marine food web. So they'll go from the water into plankton, fish, and ultimately end up in top marine predators such as the marine mammals. And because marine mammals eat a lot of the same fish that people do, anything that ends up in marine mammals, also there are human health implications to that. So marine mammals really serve as an excellent sentinel or indicator species for the entire ocean environment, as well as indicators for human health. And so this is the premise where for our very first PFAS project, where we looked at PFAS in marine mammals from the Gulf of Maine. Now, how we do this work is by collaborating with organizations who are members of the National Marine Mammal Stranding Network. So these are the organizations who have federal permits to interact with dead or stranded or injured marine mammals. And from those organizations, we can get tissue samples, which we can then send to other labs for toxicology analysis. So our very first study, which was actually published in 2009, so this is work from over 15 years ago. This was one of the very earliest studies of PFAS in marine mammals from our region. We had liver samples from harbor seals. These are seals that all died of natural causes. We had 68 individuals. It was a mixture of adult males and females and pups that stranded between 2000 and 2007. These seals came everywhere from the most eastern point in Maine all the way down to Long Island. So this data set is very representative of the entire Gulf of Maine. We had these tissues analyzed for 10 different PFAS compounds. And what we found is that the youngest animals, the pups, actually were more contaminated than the adults. We did find PFAS in all of the samples we analyzed, but the young ones were more contaminated than the older ones. And that means that the young pups are getting exposed to PFAS from their mother's milk or possibly in utero, because most of these pups were too young to have started eating fish. And this is of great concern because these are young, developing animals. This is another stress on their likelihood of surviving their first couple of years. When we compared these results to other studies published at that time from around the world, the levels from the Gulf of Maine were very in the middle of the range. They were comparable to other industrialized regions of the world. Now, moving forward, we want to build on this first PFAS study. So, as Charlie already described, PFAS were invented in the 1930s. Their use greatly increased throughout the rest of the 20th century. And then in the early 2000s, studies started to come out showing that there were PFAS in wildlife from all over the world. Additionally, when a large sample of blood from Americans was analyzed for PFAS, it was found in 98% of Americans. So it was very clear that there was a problem. In response to that, the US, other countries, even some at the state level, started to implement regulation. And manufacturers also voluntarily removed some of the compounds from the market. So things really started to change in the early 2000s. So we want to try and get a sense of this change in PFAS use by looking again at marine mammals. In our tissue bank here at Shaw Institute, we have seal samples that date all the way back to 1991. So well before we were even aware of how big the problem was. And we have samples between our tissue bank and those of collaborators that go all the way up to the present. So nearly 30 years of marine mammal samples. So we want to use, since the marine mammals really accumulate everything that's in the ocean, they can show us whether or not there is a change in contamination over time and whether or not there's been an effect of the regulation and changes in use that have occurred. To do this project, we have applied to the John H. Prescott Marine Mammal Assistance Grant to do a study to analyze PFAS over 30 years to see if we can see this change. We will also be looking at differences in contamination based on age, sex, or regional patterns, because these are things that often are reflected in different levels of contamination in marine mammals. And unlike our last study, with this new study we're hoping to do, we want to take it a step further and try and answer the question, so what? I mean, we fully expect that the seals will have PFAS in their bodies when we analyze them, but we want to try and get a sense of what effect this might be having. So in this study, we're also going to analyze various biomarkers of health effects to try and see what effect this might be having and relate that to the PFAS levels. If we get this funding, it will be a very large collaborative study with NOAA Fisheries, which will be the source of the funds. We're going to work with a new company based in Maine, Maine Laboratories, for PFAS analysis. We'll also collaborate with Allied Whale, that's a member of the Marine Mammal Stranding Network, as well as other organizations. We have a colleague who's a marine mammal veterinarian at the Center for Wildlife Studies in Portland. And then the biomarker analysis will be done at NYU University at their metabolomics laboratory. So if this funding comes through, we're excited about a very big collaborative project, and we should find out about these funds in September sometime. So definitely stay tuned. So in addition to the marine mammal work, which really gives kind of a big picture of the entire Gulf of Maine region, the last few years, we've also done much more local work focused here on the Blue Hill Peninsula. This started in 2021 when the state of Maine passed a mandate that required all public water systems. This includes schools, childcare facilities, other group living situations, to test their water for PFAS. And this law also set an enforceable limit of 20 parts per trillion for the sum of 6 PFAS compounds. And as a result of this required testing, a number of very small schools were surprised to discover that they had PFAS in their well. I'm sure you saw lots of news articles come out over the last few years. This map shows state results from Hancock County. And in our area, there were elevated levels down in Stonington and Deer Isle, some in Blue Hill, also in Surry, Mount Desert Island. So many schools discovered PFAS contamination. So we'll look a little, zooming in a little closer to our area. In Blue Hill, there were a few places that found elevated PFAS. This included at the Blue Hill Consolidated School, where they had quite high levels, the nearby Blue Hill Terrace apartments, as well as at Parker Ridge, the senior living center. Additionally, in nearby Surry, there were elevated levels at the elementary school there as well. And this last result, when we saw the news article there, that really struck home for me, because I happen to live in Surry and I've had 3 kids go through the school. So when that news came out, Charlie and I talked, and we decided we were going to approach the town of Surry to see if they wanted to look into this a little bit further. So we proposed doing some additional testing around the school to see if we can figure out the extent and also some possible sources of the local PFAS contamination. And to do this, we wanted to use a new tool that we had just discovered and tested out. A company called Cyclopure makes very easy to use PFAS water test kits, which are analyzed with EPA validated methods. And they're also much more affordable to use as compared to the state accredited labs. So using this really flexible, affordable tool, we tested in the first round 8 locations right around the Surry school. So the school is here. We tested at the town office across the street, as well as at a town park. And then we tested some surface water at Patton Stream here, flood stream, and also an intermittent stream near the soccer field. Additionally, free testing was offered to private residents who were interested in having their water tested right around the school, so both north and south of the school, and tests were made available to residents elsewhere who were interested in having their water tested. So what we found is, first, at the school, we confirmed that yes, there is high levels of PFAS at the school well. You'll notice here that this says 74 parts per trillion, which is really different than the previous slide, which said 43 parts per trillion. And the reason is that the Cyclopure lab actually analyzes for 55 different PFAS compounds, where the state data is the sum of just the 6 compounds that are included in the state mandate. So it's the difference. There are a lot of compounds included in this total that were not included in the state's total of 6. So in addition to the elevated levels at the school, we actually discovered elevated levels in a small intermittent stream flowing through the woods here between the town office and the town soccer field. And we discovered elevated levels at the pump at the small town park located south of the school. Of the private residents who had their well tested, there were no detectable PFAS in the homes to the north of the school, but there was some in a few homes to the south of the school. Although in the homes, the levels were not as high as either the school or the town office, or the park, the well at Municipal Memorial Park. So we took this first round of water tests to the select board and also presented it to the Surry Conservation Commission. And as a result, there were some very long-time residents of Surry who came forward, and they said, I remember when the school was being built in the 1980s and the soccer field was being built, and I remember that there was biosolids spread as fertilizer to encourage the grass to grow. So that really gave us the clue that we should be testing the soil at both of these locations. So on the soccer field, which is very close to this intermittent stream, we collected 2 point samples of soil. And at the school, we did pooled sampling, which means in broad areas, including the softball field, the entire baseball outfield, a strip of grass, which was the old leach field, and then grassy areas around the playground. And each of these fields, we took cores of the topsoil, pooled them together into a big container, removed rocks and soil, et cetera, homogenized them, and then took a subsample to send to the lab. So the results that we get are really an average of this entire area. So we found that indeed on the soccer field, there were relatively high levels of PFAS in these 2 samples. And then there were lower levels, but still some detection on the school grounds, on the old leach field, as well as a little bit on the playground. There was basically none on the outfield of the baseball field and the softball field. So to dive into these results in a little bit more detail, I'm going to orient you to these graphs. First of all, on the left are the 3 water samples that had some detection: the elementary school, the Memorial Park, and then this is the Osgood Trail stream, that intermittent stream. On the right are the 6 soil samples, the 2 from the soccer field, and then the 4 pooled samples from the school. In these bars, the total concentration in each sample can be read from the top, but the different colors represent the different individual PFAS chemicals. And on the legend here are the number of carbons in the molecule. And the only reason that's important is you may have heard about short chain and long chain PFAS. So short chain are generally things that are 8 or fewer carbons, where long chain are greater than 8. And you can see, the other thing to point out is that I used the same color scheme on both graphs. So PFOS is here in green in the water, and that same green is PFOS in the soil. But you can see that there are really different color patterns between the water and the soil. And that's because the kinds of chemicals found in water tend to be really different from soil. We have shorter chain compounds in the water versus longer chain in the soil. But the one thing that I wanted to point out about the water samples in particular is this box right here, the compound that actually contributed the most to the water contamination at the school is a 10-carbon compound, PFDS. And you'll notice that that doesn't show up in either of the two water samples. And when we've now actually done close to 50 of these cyclopure tests all around the Blue Hill Peninsula. And at the Surry School is the only place where PFDS has showed up. I did some literature review looking at other studies of contamination in water, and this compound is very rarely reported, or if it's reported, it's at very, very low levels. So this is a really unusual result. When we look at the kinds of products, what might be sources of PFDS, it is present in some firefighting foams. It's also present in some kinds of floor cleaners or floor polishes. So we had a conversation with the Surry Fire Department, and they confirmed that they have no documented use of firefighting foam in Surry at all. So we don't think that's the source of this compound. It's possible that there's something in the school that's has been used, washed down the drain, goes into the septic field, and may possibly be getting into the well. But I would like to emphasize that this is a hypothesis. We haven't done any follow-up testing about this, but there is definitely something interesting going on at the Surry School that deserves more study. In the soil, as I mentioned, it's mostly longer chain compounds that are left in the soil. And this is because soil that's left out in the environment, it gets rained on. The shorter chain compounds are much more soluble. They tend to release from the soil and go into the groundwater. The longer chain compounds stick to the soil particles and they're more stable. And so you're more likely to find these in soil samples. Now, you may be asking, what do these numbers mean? In the grand scheme of soil contamination that's reported in Maine, these levels are not that high, but they're certainly higher than background soils that are not contaminated at all, like those that we found on the baseball field. So is this of concern? I want to emphasize we're not toxicologists or doctors. We're not qualified to give health advice. However, even the toxicologists and doctors have a difficult time in saying whether or not this level of PFAS in soil is of specific health concern, because there's been very little research done on direct exposure from soil to skin, which is what might happen on a soccer field. There's been a lot of research on exposure from drinking water. A lot of science has gone into drinking water thresholds. Additionally, there's been a fair amount of research looking at soil and agricultural fields, looking at the accumulation to crops or how it goes from soil to farm animals and then maybe to milk. But we don't know that much about the risks of occasional contact directly to the skin. So all we can say is just my opinion as a parent is that in the grand scheme of things parents have to worry about for their kids, I would be much more concerned about whether or not my water was contaminated or the kinds of products I used in my house. If my child was playing soccer on this field, I would strongly encourage them to go take a shower after playing soccer for many reasons, in addition to just rinsing any stray soil off their skin. But to me, it seems like a low on the worry spectrum, but that's not a doctor's opinion. And at this point, that's where we would have to leave it. So in conclusion from Surry, undocumented biosolid spreading on both the soccer field as well as the original school leach field is probably one of the sources of the well and stream water contamination in the area. And given that interesting profile at the school well, there's probably something else going on there that we still need to investigate further. The Surry School has now installed a filtration system as of last summer, so their water is now safe. But there are other homes in the neighborhood of the school that may also be at risk if their wells are accessing the same groundwater as the school. And so we strongly encourage those wells, that people have their wells tested. Additionally, I want to emphasize that the cooperation of the Surry Select Board and Surry community members was really critical for the success of this kind of work. Longtime residents of Surry who spoke up about their memories and things that are just not documented in any other way was really important in order to provide clues of how to do this kind of investigation. And we hope that the study can serve as a model for other small communities that are experiencing similar recently discovered PFAS contamination. So lastly, I want to tell you about another study we're hoping to do this summer. We want to take what we've learned in Surry and bring it to Blue Hill, which, as I've mentioned, Blue Hill also has a number of sites with elevated PFAS contamination that have been discovered. So we have been working with the Blue Hill Select Board, and we have applied for funding to the Maine Outdoor Heritage Fund. In order to do some additional testing in Blue Hill, we plan to test a number of sites of surface water, as well as municipal buildings, businesses who might be interested. And additionally, we're hoping to test quite a large number of private wells in order to figure out the extent and the distribution of PFAS contamination within the town. This data will be really important for informing the comprehensive plan and for future water management decisions. If we get the funding, we want to offer these cyclopure test kits at low or no cost so that anybody who is interested in having their water tested will be able to do so. So we should hear about this funding in May. So again, stay tuned and hopefully we'll have more news about this coming up. So you've now learned a lot about the concerns about PFAS and where they are, and you may be wondering what you can do to reduce your own risk of exposure. And one of the most important things is if you are like more than half of Maine residents where you're relying on private well water for your drinking water, you really should have your water tested. If you happen to be in a part where you have access to municipal, those municipal sources are generally tested and those data are available. So you can contact your water supplier and get those results. But if you happen to find that there are PFAS in your well, there are a lot of treatment options. This ranges from whole filters using activated carbon or reverse osmosis, or you can even have just small pitchers that filters drinking water on a small scale. Although if you go the filtering pitcher route, make sure that it is certified for PFAS removal because not all water pitchers do. Additionally, as well have stain-resistant coatings or waterproof coatings. You may not know whether or not they have PFAS, but the risk is pretty high if you know that they have waterproof or stain-resistant coatings. And this includes some takeout food, wrapping materials, carpeting, some clothing, cosmetics, and even some kinds of cookware as well. If you have any really old non-stick frying pans that may be scratched or chipped, if at all possible, it would be good to replace those. There are a lot of modern frying pans that have excellent non-stick coatings that use ceramic, and if you look for the PFAS-free label, you can be confident that they are safer. And lastly, pay attention to fish consumption advisories. There's a lot of testing that happens in lakes and ponds of the fish there, and if high levels are found, the state publishes advisories about whether or not it's safe to eat the fish from those sources. So definitely look into that. So just some final take-home messages. PFAS are found in many places throughout Maine, in water, soil, they're in some farm animals, in some wildlife. And we know because of their environmental stability and known and presumed health effects, we really need to continue to pay attention to this public health issue. We need to do more monitoring. There needs to be funding for research to understand pathways of exposure and potential health effects. Additionally, more research into technologies for removing PFAS and substituting them for safer kinds of chemicals. And as Charlie mentioned, Maine is really at the forefront of this public health issue. There's a lot of news that comes out of Maine, but that's not because the problem is isolated to Maine. PFAS contamination is a problem everywhere, all over the US and really all over the world. It's just that Maine is putting attention and resources into investigating contamination and then helping people fund mitigation. And this is actually a map that the state of Maine puts out of all the known sites where biosolids have been spread. So the Department of Environmental Protection is in the process of investigating all of these sites. So that's about all I have. I'd like to thank you for your attention to me and to Charlie. If anybody out there is interested in having your water tested, we do have CycloPure test kits here in stock at Shaw Institute, so definitely reach out to us. And at this point, I think we can take any questions.
Great.
Thank you both. Well, we did have some questions come in that I noticed Charlie was typing some responses to. I feel like it could be good just to like name one or two of those in case other people are curious. And then we'll move to the open unanswered questions if that sounds good to you.
Yeah, certainly. And we got a really good question about nonstick frying pans, and asking if it doesn't get over a certain degree, is it releasing PFAS? So it's been recommended that if you do have a nonstick pan that you cook at a lower temperature, so medium to low, that's not to say it won't release PFAS into the food, but it has a less likelihood that it happens. As Michelle said, it's good to transition to something that says toxic free, or what she had mentioned before. And then avoid the use of metal utensils when you're cooking it. So it's better to use something like wood so that you don't, again, lead to more of it coming out of the pan itself. And so that was a really good question. And then I think Michelle had answered the long chain, long lasting question. We talked about free water tests being available. If the grant is successful, then I think a lot of the residents of Blue Hill will be able to take advantage of that. And then if not, we still offer our tests significantly cheaper than what the state offers. So maybe Michelle, if you want to, so let's see, you want to answer some of these, maybe the raincoat question, or we got another one from Lisa.
Okay, let's see.
I'm happy to read one to you. Lita asks, should we throw our raincoats away? I have one that is probably 15 years old and is still in good shape.
That is a really good question that I have been asking as well, because I have a Gore-Tex raincoat myself. Gore-Tex is one of a PFAS containing compound, and I guess I don't know the answer to that question. I've been holding on to it because it's still in good shape, and I don't know how to safely dispose of it. So I don't know, Charlie, if you have anything to contribute to that, but that's a very good question.
I have a tendency to look up the brand and the model and whatever I can extract from the label to see if there's any sort of report about it. Generally, if there's been something that's come out, then you'll see it somewhere online. But yeah, I think a couple people are actually asking kind of the same question in terms of, if you do find something like that, how do you dispose of it? And we don't have a lot of options. I mean, landfilling is going to probably be your best bet there. And what we really want to avoid with things like PFAS chemicals is the situation where you're going to take it from a certain location and remove it so that it's more volatilized and can reach other environments or your body. And that's going to involve areas with like high amounts of heat, mostly if we're talking about this. So if it's going on like a Gore-Tex coat or something into a landfill, as long as it's not being burned, then it might be a slow release, if anything. So unfortunately, your best option is to just landfill it, is just get rid of it. And I wish there was a better answer for that, but unfortunately, that's what we're dealing with. And then there was another really good question about our PFAS testing. So the state, it kind of varies in between different places. It can be 350 to 450 per test, depending on the substrate. We're lucky with CycloPure that we can get the cost down to around $100 for 55 chemicals. And it's a really quick turnaround time. The state can take pretty long just because there's a big backup. But we're able to get ours back within weeks, which is pretty great in comparison. And then Lita actually asked another really good question. If you live in a forested area, the risk of PFAS pretty low. It's kind of funny. We went into this super isolated lake, or I think maybe it's a lake or pond nearby. We had to hike through dense woods to get there. I went with one of the interns because we wanted to control. We wanted to find an environment where there wasn't a lot of PFAS contamination. I thought going to this place, that would be a good example of an environment that didn't have high PFAS levels. It didn't necessarily have high PFAS levels, but it had PFAS in it. So it's hard to say. I think if you live in a forested area and there's not a lot of industrial facilities around you, then you might have a lower risk of PFAS contamination. But it's tough for us to say without going out and doing the testing. We can't say that it's going to be zero, but yeah, there might be a lower likelihood if you think about what you're exposed to. Now, that said, as Michelle was saying with the Surry school, if there's someone nearby that's using something that ends up in the environment, it's hard to say. That could be another source. But Michelle, I don't know if you had anything to add to that.
Yeah, I guess the only thing I would add to that is that it depends on whether you're talking about your water in a forested area. Excuse me, I'm getting over a cold, so my voice is giving out a little bit here. Groundwater can travel very strangely, and oftentimes we have no idea. One thing I meant to point out at that map of Surry is it was high at the school and it was high in that stream, but the town office, which was situated right between the school and the stream, had very low levels. So if you're in a house and you have a well, you don't know where that water is traveling underground. So it's still worth having your water tested.
Can we go up to that upper question from Lisa? It's kind of a technical question, but I just wanted to make sure we hit it before we move on. Lisa asks, we have an ultraviolet light filtered whole house filtration system. Private wells were tested on Deer Isle in 1122, and ours has very high levels of PFBS 133 and M2 2 FTS 162. Will our system filter out these?
Well, I mean, we have a certain expertise, as Michelle talked about earlier. We're not necessarily experts on the system. We know that RO systems, for example, have shown to be pretty good with PFAS. It's an interesting situation that you have. I honestly, if it was me, I would just test it to see how efficient the system is. Or I would call the company that installed the system to see what their removal strategy or removal rates are. That's what I would do. It's hard for me to just look at this and say whether or not your system will filter them. Now, it's great that you have a whole house filtration system in there. I think that's a great start. But I would contact the company and say, what is your history with dealing with these chemicals, and is my system adequate to be able to handle that? But Michelle, I don't know if you had anything to add.
No, I agree. Filtration systems are designed to filter out different kinds of things, so it depends on what yours was designed to remove. But it doesn't hurt to do a test on the far side of your filter and just see what is coming out of your tap. That is, for peace of mind, it's always worth doing a post-filtration test to just find out what you're actually drinking.
I think we've got a really good question, Michelle, about the study, marine mammal study. So what specific biomarkers are you intending to use in your marine mammal studies? Presumably you could use these to monitor live mammals.
Right. So if we were studying live mammals, it would actually be easier because then you can measure things in blood that are representative of what's going on in that seal right then. since we are using samples from stranded dead marine mammals, it's actually kind of a challenge to figure out what we could measure, because we have pieces of blubber or liver that some have been sitting in the freezer for 30 years. So what we're going to do, and this was in consultation with the metabolomics laboratory, is we're actually going to analyze PFAS in liver samples and then take blubber samples from the same animal and have them analyzed for markers. It's called lipidomics. So it's things that tell us about whether or not the animal was able to process fats effectively. PFAS have been linked to some metabolic disorders like fatty liver disease. And so we'll be able to get a clue as to whether or not that system within the seals was functioning correctly. But it was a challenge to figure out what kind of biomarkers would be meaningful and accurately reflect some aspect of the health of the seal, when what we have is samples from the freezer from dead animals. And we don't know how long those seals had been dead before they were found and the samples were removed. Doing studies, this kind of study on live animals, is challenging, as you can probably imagine. So that's not something that we are planning to try, but there are definitely other research groups that do collect blood or blubber biopsies from live animals, particularly cetaceans, and have done these kinds of studies before.
Great. Noel, do you
We've got,
have a question?
go
And
ahead.
go from there.
Yeah, looks like we have just a couple more minutes. So maybe this would be a quick one. How should we dispose of old cookware?
That's a landfill for sure. Just try to get it in a place where you don't have high heat, high amounts of, exposure to area or to situations that can pull those chemicals out of it.
Great. And Carolyn asks, how much do these test kits cost if not in the study area?
Those are about $100. Again, much cheaper than the alternative.
And that includes, well, the results report, as well as a letter explaining what the results mean and what you might be able to do about it. So there'll be information included. If you purchase them for us, we will help you interpret what the results mean as well.
Is there any reason why cultivated blueberry fields might see higher levels of PFAS?
I don't think anything. So fruits are actually shown to not have as high of levels, but I think it would be contingent upon the treatment of the soil there, that maybe there was just a heavily, sludge application done in that certain situation, and that sludge had quite a bit of PFAS chemicals in it. I wouldn't think that blueberries themselves are the reason why there's high PFAS levels, but again, there's a lot of unknowns with this work.
Yeah, there's still a lot of research going on at like how plants accumulate PFAS from the soil. So there's a lot of unknowns. From what I've read, a lot of plants will collect it in the roots and maybe to some extent in the leaves, but it doesn't make it into the fruit. But it does seem to vary a lot with the kind of plant you're looking at. So I don't think I've read anything about blueberries specifically.
Cool. Thanks for answering that, you guys. Lita Beth asks, can you absorb PFAS through your skin? Like if your filtration system is just for a drinking water tap?
It's not absorbed well through the skin. Low amounts can go that route, but generally speaking, that's not going to be one of the leading exposures. It's just the way that the chemistry works. It won't be. I would be more concerned about drinking the water and maybe ingestion routes than through your skin.
Yeah, I mean, I think there's some research specifically related to firefighters who are wearing protective gear that has some PFAS in it, and they're exposed to really, really hot, intense, sweaty conditions. And under those conditions, they can potentially absorb some through their skin, but the levels that might be in your drinking water, it just seems like a very low risk there.
Awesome. And Mary says, thank you for a great presentation.
Thank you.
Thank you.
Mhm.
So
All
if
right. Well,
go for Noel.
All right.
yeah, I was just gonna say thank you both for being here, for helping us understand a little bit more something that's been intimidating for a lot of people and confusing. So we're really grateful for both of your time and the thoroughness of that presentation. And I know that Maren, do you want to mention the recording?
Yeah, so if anyone wants to watch this again or check it out at a later date, then they can find this recording on our YouTube channel. If you just go on YouTube and search for Blue Hill Heritage Trust, you'll find we have all of our past Friend from the Field webinar series on there. So yeah, you're welcome to check those out. And thank you everyone for being here. And also thank you to our presenters. We appreciate it.
Thank you for having us.
Yeah, thank you very much. It's great to have a platform to be able to talk about this. So we appreciate it.
Awesome.
So have a good night, everyone.
You too. Take
Bye-bye.
care.
Bye.